So real quick for your warm-up, I just want to give you a little direction here. So listen up. Okay, so what you're doing is all these logs, you're just categorizing them into one of three categories. Okay? Can I do this without a calculator? Can I do this with the log button of my calculator? Or is this not quite solvable yet based on what we learned in class, right? So you would think to yourself, okay, here we go. I got one of the logs. Now, yesterday, there were three pieces to these logs, right? What were the three pieces? Base, exponent, answer. Which one's missing here? The exponent. So that's, of course, what a log is, right? A log is an exponent. So that's what you're looking for. So you can add an equals x if that helps you, right? And now you can reset this as an exponential equation. You can say, okay, well, my base is 5, my exponent is x, and my answer is 125. And then you ask yourself, can I do that? And if you can, then it goes down into this category. Now, if you get one that you know you could just plug right into your calculator, it goes into that category. And if you get one where you rewrote it, you know you can't put it in your calculator, you rewrote it, you still can't do it, it goes there. Okay? So those are your three situations. Okay? I'm going to come around and check your homework. All right, so for each of these, you would want to figure out, can you do it? Do you need a log button? Can you not do it at all? Let's go back to this one. Can I do this one?
Yes.
Yes. Why? Yeah, because this would be 5 to the third, and I can do that. And x equals 3. So that means this one, no calculator needed. Okay, how about this one? What's missing here? The base. Well, the exponent's missing in all of them. We're trying to figure out if we can find the exponent. But the base is what? 10. Whenever the base is missing, it's 10. It's like so common that they don't even write it. Okay? It's also so common that there's a button for it on your calculator. So if you get this, you can just literally say log 44 on your calculator, press enter, and you get the answer. Go ahead and do log 44 on your calculator. What do you get? Underneath the second?
1.64345.
All right. 1.64, we'll go with that. So can somebody tell me what this means?
It's log button.
What else can I infer from this? The exponent of what? What's my base?
10.
So tell me that as a sentence.
10 to the 1.64 equals 44.
Exactly. Yep. So you just learned what 10 to the 1.64 is. Okay. Moving along, well, what do we know is going to happen anytime I have a missing base then? We can use the button. So that's this one, that's this one, that's this one, and that's this one. Right? Now the rest of them we have to kind of think, can I do the other thing? Okay, so for instance, this next one to look at, I'm like, okay, equals x, 6 to the x equals 45. Okay, so I think to myself, well, 6 squared is 36. 6 to the third, I put it in my calculator, and it's this massive number, right? So I passed 45. So what does that mean? You can't do that yet. We don't know how to do that yet, right? So there isn't no solution. We just haven't gotten there yet, okay? So this would go into the not solvable yet category, okay? And you would go on and do that for every one of these. Now, any of these that we're not sure about? 5. They're not even numbered.
No.
I'll do both. All right. So this is x. 5 to the x equals 38. Could you figure that out? No.
So it's not solvable.
Not solvable. This one equals x. 6 to the x equals 1 over 36. Do you have a feeling that maybe you could figure it out?
Yeah.
It's 6 to the negative 2. Why?
Oh, because it's a fraction and 36 is
can rewrite 1 over 36 as 1 over 6 squared, right? And then 6 squared can come up top and become 6 to the negative 2, and that you could do. And now you have common bases. So this one would be
Not calculator.
no need for a calculator. Okay? All right. Any other questions on these? Okay, cool. Hopefully that helps you kind of differentiate between what you can do, what you can't do at this point. Okay? Now, moving along. What we're going to talk about today are some properties of logarithms. So just like properties of radicals, properties of exponents, they allow us to kind of work with these things more because we know what we can do with them. We can change things to a format that is solvable when it wasn't solvable, evaluatable when it wasn't evaluatable, and I'll tell you what I mean by that. Now, in order to talk about these properties, we're going to talk about properties we already know. Why? Well, what is a log? A log is the exponent, right? Logs and exponents are very much related. We can call them cousins, right? They have all the same pieces, just in different places, okay? So, if you can go back and forth between logs and exponents, surely their properties will be similar too, okay? I'll show you what I mean. Now, the product property. Product is when what does the word product mean? Multiply. And you're correct, when we go from multiplying to what? Adding, right? And remember, it looks like this. You would have like m to the n times m to the, wait, did I miss? I don't, oh, a, I just want to be consistent with the way I've done it in the past. A to the m times a to the n equals a to the m plus n, right? You just add the exponents. I know y'all like examples with real stuff, so let's say x squared times x to the third equals x to the fifth, right? So we go from multiplying to adding, right? Well, the same is going to be true for the log property of product, right? You're going to have log, and let's say you have log m times n. Well, that is one log, right? You can break that apart into two logs that are adding. So it becomes log of m plus log of n, right? What's that? Multiplying m times n, adding, right? So you go from multiplying to adding just like before. Here's my multiplying, here's my adding, right? What you want to do is kind of think to yourself, okay, if this is like the inside of a log, right? Then we'll call this the outside, right? See how it's outside, it's like in front of the log? And this is kind of like inside. Okay? Well, if I see multiplying on the inside, I can do adding on the outside. Okay? So we would say multiply on the inside, we add on the outside. Or the other way around. If I see adding on the outside, I can do multiplying on the inside. Now, again, I will show you real examples, right? Let's say you have log of, let's start easy. We'll go 3 times x, or 3x. Well, I can rewrite that as log of 3 plus log of x. Okay? I was multiplying on the inside, so I can pull it apart into two logs, and I add. Okay? You could also go the other way. You could say, well, I have log of 5 plus log of 2. Now, does anybody here know log of 5 or log of 2 by heart? No, I don't. Let's see what happens when we bring it together. This becomes log of what? If I'm adding on the outside, I do what on the inside? Multiply. So it's 5 times 2, which is what? So this is really log of 10. Does anybody know what log of 10 is? It's 1. Very good. How'd you know that?
I remember you saying it, but it was really a shot in the dark.
It's a good shot in the dark. What's the base there? Let's analyze this for a second. So I have log base 10, answer 10, and I'm looking for my exponent. 10 to the what is 10? 1. So we've kind of discovered something here, right? If you have log base x of x, it equals 1. If you have log and your base and your answer are the same thing, that's 1. The only way to have this be the case is if it's this to the 1 is this. Right? Does that make sense? Good.
10 to the 0 that equals 1?
Well, that would be if 1 was your answer.
Oh, never mind.
That's your exponent. But you hit another one that we're going to talk about. Okay, let's talk about the quotient property first. Okay. Our quotient property for exponents was a to the m over a to the n, and then we would say, oh, that's a to the m minus n, right? Or you might have like x to the 7 over x to the 4, and you know that that's x to the 3. So we go from dividing to what? Subtraction. So what do you think is going to happen with our logs? Exactly. Yep, so it looks like this. If you have log of m divided by n, that equals, so that's 1 log and it's on the inside. You break it into 2 logs and you say that's log of m minus log of n, right? So correct. You would, if you see dividing on the inside, you can subtract on the outside. If you see subtracting on the outside, you can divide on the inside. I will give you some examples. If you have, say, log of 20, sorry, I forgot the base. Log base 4 of 20 minus log base 4 of 5. Well, what am I doing? I'm subtracting on the outside of the log, so that means I can divide the insides, right? So I say log base 4 of 20 over 5. Can we do 20 over 5? Yeah, it's 4. Log 4. What does that equal? 1, right? We just learned that. Good.
Shouldn't it log base 4 over to the 20 over log base 4 over 5, or no?
No, you have to combine them into 1 log. It's not log divided by log. They get divided on the inside of 1 log. All right, let's going the other way. Let's see. If I had log, I don't know, 10/3. I don't know 10/3, but I know that if I'm dividing on the inside, I subtract on the outside, so I would go log of 10 minus log of 3. Can I do anything else with that?
Log of 7?
No, you can't. It's not like that. They're not like terms. Think about each log at a time. Can I evaluate either of those?
I think log of 10.
Log of 10 is 1. So I would say 1 minus log of 3. Okay? All right. Ready to move on? Okay. we'll practice that today. Now, that's it. Like those are the skills, okay? Now we're going to use them in a couple ways. Okay, here's one situation you might have. I give you certain logs that you didn't know. Like I tell you, hey, I'm just going to tell you log base 2, 3 is 1.585, and log base 2 of 7 is 2.807. So you know that you know those now. And you're going to be given things you don't know. You're going to change them and use these to find a real number. Okay? Now, let's also talk about other logs that we know with base 2 that weren't given, but we should know now. Any other ones? Think about what we did in the front. Think about the rule that we discovered.
Log whatever it is by itself, like if the base is the same and the answer is the same, it always equals 1.
Exactly. So I know that too, right? So if this shows up, I can deal with that too, right? And there's another one you hinted at, but we didn't really talk about.
Oh, is it about the fact that if the answer is 1, but the number...
So think about that. The answer is 1. The base is 2.
It's always going to be 0.
Always. And that's true for anything. Like you could say log of any number 1 equals 0. Okay? All right, so we can add that to our package of what we know. Okay? Now, let's do what we just practiced. Okay, what's happening here? I have one log, and I'm going to look inside of it, and I see division, so that means we will subtract. So I'll go log base 2 of 3 minus log base 2 of 7. Okay, why was that helpful?
Because we know log base 2 or base 2 of 3.
Yeah, what is log base 2 of 3? 1.585. Yep, we know the other one. It's 2.807. So you can see how we had no idea how to do this, but we got to a place where we could do things, right? And now if I do that math, I get... Yep, negative 1.222. Right? I got to an answer. Okay? Similar process all the way down. Log base 2 of 21. That one's not as obvious.
Well, it's
This time
It's
this
3
is
times
1.5.
It's 3 times 7. So you're saying that 21 is the same as 3 times 7.
Yes.
Okay, so let's write that. Log 2, 3 times 7. Now what do I see? Multiplying on the inside, so I would do addition on the outside. Good. Log base 2, 3 plus log base 2, 7. I know the pieces, right? So I plug them in. I got 1.585 plus 2.807, and that is 4.392. Good. All right. Why don't you all try this one? See if you can figure that one out. Actually, if you want, try the rest of them, and then I'll pop back in. Log of 2 base 49. What does that have to do with anything? It is 7 times 7, so I can rewrite it that way. Log base 2 7 times 7, and that's log base 2 7 plus log base 2 7. Or, as we know that to be, 2.807 plus 2.807, which is? Yep. Okay. What about this one? Because I don't know how to combine 7 and 3. I mean, sorry, 7. Yeah, it was 7 and 3 to get 6.
It's 3 and 2.
Ooh, 3 and 2, but...
3
They didn't give us 2.
It's 2 and 2 equals 1.
That's right. So we would say you don't want to forget about that option, right? So this is actually 2 times 3. Good. And then what do I do?
You add it.
So log base 2 of 2 plus log base 2 of 3,
Which means it would be 1 plus log 2 of 3,
which is,
1.585.
or in other words, 2.585. Good. Make sense?
So it's like
Yeah.
I'm missing something on the 49 ones. They're not serving me as get 4 decimal places.
Oh, did I write that wrong? Yes. It's been a long day. Okay. Last piece. This is your practice before I hand out your homework. Okay. Now, you need to be able to go back and forth with all of these. So you got to ask yourself, subtracting on the outside, adding on the outside, multiplying on the inside, dividing on the inside, and again, go the other way. Okay. For example, what is happening here? Subtracting outside the log, right? So we're going to divide inside. Now, the condensed, that means bring something together. So this will be 1 log, right? And over here, we will have multiple logs, 2 or 3, right? So you're either pulling apart or bringing together into 1. So I just had the 1 log, and then I would be x divided by 9. Right? Okay. All right, go ahead and try them.
they don't have the same base. Do we also like put them together?
Interesting question.
No, it's like
Why'd you have to ask after I sat down?
You just said it?
No, you didn't say it. I just waited. All classes today, I've played coy and walked away, and then I go, wait, I gotta wait. Teacher, I see something that's amiss. What's wrong here? That's 10, right? Remember exponents? Like when we had like x squared times y to the 3rd, and there were different bases, could we just say xy to the 5th or do anything with that? No. We leave it alone, right? Not the same base. So we can't do anything, right?
So it's the exact same.
Yep, you would leave it. It's simplified. Good job. Just so you can see them, when you verify your answers and you feel good, then you can grab your homework. Yes.
It's the question that I have. Never mind.
Okay, I'll come over.
This one?
Oops.
Log of 3.
Yes. 12 divided by 4 is 3. So, yep, if you rewrite it that way, then you can do it.
Yeah, that's right.
All right, those are your answers. Once you feel good, come grab your homework. Now, for the homework, this was just about getting to know logs and their relationship with exponent and exponential expressions and equations, okay? So the first section was, hey, here are some exponential equations. Can you make them logs? The next one was, here are some logs. Can you make them exponential equations? You just kind of go back and forth between the two, okay? Would anybody like to see anything from section 1 or 2?
4. Oh, 1 and 2.
Okay. So your basic thought process here is, well, if this is my base, right, then it needs to go in that spot in the log. Okay? if this is my exponent, it goes over here. And if this is my answer, it goes right here. Oh, I missed.
What's
What?
the point? Like we just transfer one thing to another?
Yeah. No. The answer to the exponent goes there. And then in this case, your exponent is the log. Okay? All right. So that's the case for all of these, right? And if you were going the other way, like for instance here, now I have a log that I need to turn into an exponent, right? Well, I see that this is in the base spot. Bottom is for base, right? So that goes to the base of my exponent. The exponent over here, it's always on the other side. It's the answer to this log. I shouldn't use the word answer. The log is the exponent, is being the equal sign, so it's over on the other side. That's your exponent. And what did I not use? And then your exponent is your answer. Man, I'm really fumbling this. Your answer goes right there in the log, so it comes back out. And it should make sense. 7 to the third is 343. So log of 7, 343 equals 3. Okay? That's the basics of it. Now, you use this sometimes when there's a missing piece, and that's what the next section was about. The next section, sometimes the base was missing, sometimes the exponent was missing, sometimes the answer was missing. Okay? So you had to be able to find each one based on what was missing. So first you would rewrite it just like we did above, and then you would solve. Anybody want to talk about any of these? What's that? 12? Okay. So 12. Here, if I pretend that this answer isn't here, right? I know that the bottom part is the base. I know that this part is my exponent. I know that this part is always my answer. So I set up a new equation. X squared equals 361. To solve for x, you would square root, and the square root of 361 is 19. Okay? That's that one. If you got just x as your answer, well, that's easy. You just evaluate the other side. If you got x as your exponent, you'd have to kind of think that through or use common bases. 9 to the what is 81? Well, 9 squared. Okay? All right. On to the back. Anything on the back? 17 or 18? Okay, so 17. Here, let's get the answer off the screen as much as we can. All right, so if I was doing this, right, and I'm like, okay, here's my log. This is my what? Base. So I say, okay, 1, my goodness, 1/5 is my base. And I know that x is my exponent, so I'm going to go to the x equals 1. Well, here's a problem. I don't know my 1/5 to the whatever, but I don't have to. Why?
Because if you put an exponent 0 to the 1.
And the only way to get 1 by raising to an exponent is if the exponent is 0. So x equals 0. Okay? Which one? 15. Okay. Your base is 18. Your exponent is -1 equals x. So if anytime equals x, you just need to evaluate what's on the other side. 18 to the -1 is 1 over 18 to the 1 because it's a negative exponent, so it goes downstairs. Okay?